Imagine removing all planets, all particles and antiparticles, all possible types of radiation, all curvature of space, and all ripples of gravitational waves. In essence, leaving a completely empty space where there's nothing to interact with. Would you truly be left with nothing, or would something still exist? This state is typically referred to as quantum vacuum. It's the lowest energy state of empty space. Surprisingly, quantum physics teaches us that the zero-point energy or the base state of the universe isn't actually zero. On the contrary, it's a finite, positive value that has been observed through the effects of dark energy, estimated to be roughly equivalent to the rest mass energy of 1 proton per cubic meter. Theoretically, within our current capabilities, it's calculated to be 10,120 times higher than this observed value. There's no robust explanation yet for why this zero-point energy doesn't decrease, dissipate, or, for that matter, doesn't change over time. The nature of zero-point energy. Currently, this zero-point energy in spacetime has an 8% margin of error. However, over the next couple of decades, professors promise to reduce the error to 1% by measuring how the universe has expanded throughout its history at various distances from us. These measurements can confirm that the universe's zero-point energy is uniform everywhere. But would this be equivalent to nothing? More importantly, what about our understanding and perception of the nature of nothing? Is it an illusion, or a key to understanding the universe's most vital secrets? The problem of defining nothing. There's a significant problem in solving this riddle. We can't agree on what nothing means. While it's not an illusion, as scientists have pondered it, questions arise. For example, is it a state beyond space and time from which space-time itself arises? That is, from a truly empty state? Does such a state even exist? And would its existence be meaningful? Is it a state of emptiness in our universe that might differ from a similar state in another stack of universes? Or is it the cosmic vacuum with all its virtual energy, which can change depending on what's within it? It seems strange to assume that our emptiness might not be the same kind of emptiness elsewhere. But we believe that the Big Bang began precisely with a transition from a higher zero-point energy to a lower one, filling the expanding universe with energy inherent in space itself. This transition led to the creation of all matter, antimatter, and radiation in our universe. It's even possible that in the future, another similar transition awaits us, with a different, colder Big Bang. The paradox of nothing in physics. Such discussions aren't very comforting. This physics of nothing sounds like the physics of something. When we want to understand nothing, our ideas lead us beyond space, even before the birth of the universe. Otherwise, what's the point? How can one speak of something beyond when there's no space? How can one understand before, if there's no time? And whatever this nothing may be, an entire universe is contained within it. Many physicists argue that it's impossible to understand anything thoroughly until we understand what nothing is, because we don't understand where fundamental laws originate if we don't understand what rules govern the nature of empty space. Thus, we can say that our universe indeed arose from non-existence, from emptiness, from nothing. Its final state may tend towards non-existence for a long period of time, but only if we accept our description of physical nothing as true nothing. This definition of nothing itself cannot depend on our definition of space-time and the rules of the universe. There simply isn't a physical experiment that would allow us to say, "Aha! It seems we've finally turned this into nothing." What we know for sure, but there are things we are sure of. We haven't always existed, we won't always exist, and we exist now. Regardless of what nothing is, we are all something, and to that extent you are from nothing, whatever that nothing may be. And as far as we understand the universe, it will one day return to a state of infinite physical emptiness. The unanswered question remains: what will be the nature of this ultimate emptiness? Well, I hope you found this interesting. And finally, best wishes to everyone. Of course, subscribe to us. We have a whole bag of interesting topics, and also check out our links in the description. Add us as friends. Until next time,